Good evening, everyone. I am Dr.K.Kannan, Assistant Professor, Department of Computer Science, Dr. SNS, College of Arts and Science, and Coimbatore. Today we are discuss about the topic is middleware for fog and edge computing. The middleware is fog and edge computing is act as a software layer that bridges and the gap between the devices on the edge of the network like sensor, IoT devices and gateways on the central cloud and infrastructure. It manages the communications, is computation and storage tasks that occur the closer to the end user and data sources, the enhancing the performance and scalability and the real time, the responsiveness. The key roles of the middleware, the first one is resource management. The middleware manages the distribution of the resources, ensuring that computation is handled either locally at the edge or offloaded to the cloud based on the latency, bandwidth and energy constraint. The second one is the data processing. It helps in the filtering the pre-processing and aggregating the data closer to where it is generated, which reduce the load on the cloud and provide the faster insights for the real-time applications like the autonomous vehicles and smart cities and industrial IoT. Next one is communication. The middleware facilitates it is a communication between various devices and nodes in the fog and edge architecture. It provides the protocols and APIs to ensure the seamless data exchanges and heterogeneous environment with different device types. Next one is security and privacy. The middleware enforces the security protocols such as the data encryption and authentication and access control at the edge of the network and addressing the privacy, the concerns for the sensitive data before it is sent to the cloud. The next one is interoperability, which numerous devices and platform uses. The middleware provides a common interface and standards to ensure that different systems can communicate and work together and regardless of the underlying the technologies. Next one is context awareness. The middleware can monitor real-time condition like network traffic or device performance to optimize the placement of tasks and adjust it dynamically as condition change. The next one is middleware architecture in fog and edge computing. The first one is service layer. This layer provides the high-level services to application such as data analytics and decision-making algorithms and real-time monitoring. It abstracts the complexities of managing the lower-level resources, offering the developers an easier interface to work with. The next one is a network abstraction layer. This layer handles the communication between devices, fog nodes and the cloud. It ensures the reliable data transfers and manages the bandwidth and routes data efficiently across a dynamic and often the heterogeneous network. The next one is the device management layer. It environment with multiple IoT devices and sensors. The middleware is manage the connectivity and the registration and status of devices. It provides the services for device discovery and configuration and update the failure handling. The next one is the execution layer. This layer is responsible for executing application and services, the managing a local resources such as the processing power, memory and energy in agent fog nodes. It schedule tasks based on the factors like device capabilities and network condition and energy efficiency. Next one is a type of middleware. The first one is event-driven middleware. The focus on real-time event-based interaction between edge devices. It helps in application where low latency is critical, such as autonomous vehicle or small grids. Next one is data-centric middleware. They manage the data flow between the devices and processing nodes, optimizing the data routing, the pre-processing and storage. It is a common in application like environmental monitoring or healthcare, where large amount of data need to be processed and filtered quickly. The third one is service-oriented middleware. This middleware they provide a platform for developing and running the distributed services in a modular fashion. It allows the application to request and execute the services, enabling the better collaboration and agent cloud. The next one is message-oriented middleware. It facilitates the communication between the distributed system using the messaging protocol. This is useful for enabling the seamless data transmission between the devices and the cloud. A system is where multiple components need to communicate asynchronously. The use cases for the healthcare and agriculture, retail and industrial IoT. Next one is autonomous vehicles and smart cities, telecommunications and smart grids, the use cases. Thank you.